Hello, 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 everyone.
Hello,
How's everyone going?
I'm doing okay. How about yourself?
Oh, I'm doing good. I'm doing good. Did you guys go over the what we did last week and your account with Coinbase?
Yeah,
You sound far from your microphone, Patrick.
I'm fine.
You sound far from your
Is
mic.
it better?
Yeah.
So let me maybe increase the volume a bit. Is it better?
Yeah.
So, well, we tried, and yeah, we got. I personally got stuck at some point where they were talking about earning the $10, where it was saying that you have to have a wallet. So
Yeah.
I don't know where my wallet is.
You don't know where your wallet is. You mean on Coinbase?
Yeah. Yes.
Okay, so you need to probably create a wallet and not this one wallet. But normally those they can do that on your behalf, but you probably need to create a wallet because since the last time I showed you last time all the addresses that I had, we can probably take a look in the second part of the meeting. Okay.
Mm-hmm.
Before we had 38 minutes for the first part, do we have anybody else joining? I see Desiree, Patrick, Celestin, and Pierre-Marie.
Hey guys.
Hey, Desiree.
I think Michelle Eric still need to join, or and who else? Jean-Claude.
Jean-Claude. Okay.
Mm-hmm.
Okay, let's give them
1 minute.
a few seconds. I would wanted to say. All right. So besides the Coinbase issue that you're reporting, Patrick, anybody else had any issue? Okay. Who let me just know who completed the little short videos and got the coins in Coinbase. You did? Pierre Marie, you're mute.
Yeah, I did the short video. Those short video that give you like $3.
$3? Yes.
Yes, I get 3 of them, and I went up to the one $10.
Yeah.
And they say you have to create a wallet. So I download the app. I created the wallet. So everything, but it keep turning. He say it can take more than 1 hour to get the $10. It keep running. It spend like more than 2 hours, nothing. So
yeah. So actually, that's a good exercise. That's some. Hey, Jean-Claude.
Hello, everyone.
Hi, he said.
This is something that you probably need.
I'm running to get on time.
Yeah, no problem. This is something that you probably need a little more effort because you need to have a wallet first, a Coinbase wallet, and then what you need to do, you need to transfer some USD coin, which is a stable coin, into that wallet. After you do, you need to transfer minimum $3, they say. But if you transfer minimum $3, you're gonna have some transaction fees issues because I think the transaction fees for comps is a little high right now.
yeah, they gave me that opportunity. So if you see my screen, so I put is like they give you option that $3, you charge you some fee. So I have on the wallet like $4 something.
Right, exactly. So that's in that case, it's gonna be tough for you to do it.
The $10 that they say if you sign up, like on the Coinbase website, keep running, say you're gonna take more than 1 hour. So I let the computer run for 2 hours, nothing.
No, but you need free lunch, my friend. Yeah, you actually need to. It's a little more complicated. That's what I'm saying. If you are starting, that's fine. When you're gonna understand the whole thing, you're gonna figure it out. That's not a big deal. Okay, so let me go ahead and see. I think we're missing only Michelle. So I think we're gonna start. We have 35 minutes.
Yeah.
Let me go ahead.
To contact him, Patrick.
Then I did not contact him. I did not contact him anymore.
Okay.
send a message only to JC and he's here.
Keep going. I'll try to contact him.
All right, let me go ahead and share
I
my
think he should be
screen.
coming because I spoke to him earlier and
The only thing I really need is to know about these because the $3 that I got, is it in a wallet or is it not in a wallet?
We're
That is
gonna
where
deal
I'm
with that.
confused.
Don't worry about it. We're gonna deal with that maybe on the second part because I need to rush a little bit into the material. And what I did
Okay,
actually is
okay,
yeah, so we can get because otherwise we have 2 days left. Otherwise, we're not even gonna touch the how to make money, the trading, the investing, all those things. It's gonna be complicated. So let me just do the maximum I can do today, and then on the second part, we're gonna be having the screen sharing and like the video last time, and then we're gonna see for each person. Does that sound good?
okay,
All right.
okay.
Let's see. All right. Let me know when you can see my screen. So actually, I went back to trying to kind of do a different type of material so that it's more adapted to what you guys need because what I had before was more for advanced people, and I realized that not a lot of people are actually not only going to need it, but people are still at the basic level. So I don't want to confuse you with too much material, so I redesigned the material. I still need to add more slides. I'm going to do that as we're going, and we're going to try to go get fast into it. And if there's any material that I need to share with you to enhance your understanding, I'm just going to do it as we go. Okay. All right. Coming back to what we did last week, we had a bunch of questions. We went through why do we need a Bitcoin, the trust issues existing. We had a financial crisis. We spoke about who created Bitcoin. We spoke about how do we verify identity online using digital signatures more generally in a end-to-end transaction online. So using the key pairs, public and private key. Okay, how it is used for Bitcoin, the SHA-256 algorithm that I showed you last time, and the mathematics behind it, why it's hard to hack, and why it's possible to generate almost an infinite number of public addresses without ever having any collision, without ever having two people generating the same wallet address. Okay. So we did that. We talked about how a transaction is performed using the private key and the signature, digital signature. And I explained also how a transaction is sent through Bitcoin blockchain or network. Okay. I think the only thing that might be interesting again to look at, just to refresh everyone's memory, is go from here before going to explaining the blockchain and how the transaction works, etc., etc. Okay, questions? Okay.
Are we gonna have this slide? This one is more, I mean, it's good for me. Are we gonna have copy of this slide at the end?
Yeah.
I'd
So
like to have a copy as well.
yeah, I was saying that this is a proprietary material. We usually don't share those slides, especially for sessions like
For
this.
private use, of
For
course.
yeah, but I said last time also that if you really need that, I can give it to you. That's not. I'm fine with that. But I need to finish up and
I
add some
think, I
more.
think that's what you said last time.
Yeah.
I need one, sir, at the end.
Say that one more time.
Yeah.
What did you say?
I will need one. I will need a copy, please.
Okay. All
Well,
right. Okay.
Can you guys hear me?
Yeah,
Yes.
I can hear you. Go ahead.
Okay. I would suggest that I think that you said, Steve, last time that you could group this material in PDF, and we understand the proprietary nature, so we try not to spread it. I mean,
Right.
you can at least regroup that for everyone and then send like one copy to the entire team, right?
Okay. All right. I'm gonna work something out. That's not a problem. I'm gonna make it work for you guys. So this is what I said. I'm trying to work on the other material. It looks like it was too complex for you guys, so I trying to extract that and create another material that is more suited for you guys. So, and that's what I have. But I'm not done with it yet. I have a few parts that I need to add into it. Okay. All right. Apart from that, any questions? Okay. So what I was saying is, for a transaction to happen on the blockchain, you first need the address of the receiver, right? So the person that you like to send the Bitcoin to, and then you need to use your private key to encrypt that transaction, and you have the money that you want to send, what's the address, etc., etc. So one thing that is important to remember here is that when you're using, and we're going to speak about that a couple of slides down, maybe after the this first part, there is the two types of wallet, right? Software, because I told you last time, what is a wallet? A wallet is nothing but the storage or the application that stores your public key. In this case, is the hash version, so your Bitcoin address, and the private key, right? And the private key is what you never want to share with anyone, because if someone has your private key, he can use any money that you have into your wallet. Okay, so when you have a wallet that is online, then you can go ahead and proceed with making a transaction directly, because usually those softwares store not only stores those private keys and addresses, but it
Yeah.
also allow you to encrypt the message and do whatever we said. So get the hash version of the message, encrypt it using your private key, and then sending that out on the network. So that's what a software addition stuff that the software wallet is doing for you. And then we're going to come back on that. Don't worry if you're not understanding now. And anybody who has the public key can decrypt the message. So the public key in our case here is your address. Okay, it's your wallet address. He can decrypt the message, and he can get the transaction validated. Now, this is what it looks like. I'm not going to spend more time because I think we went through this last time. Okay, this is what it looks like. Now, you might be wondering, how does that work when you do send a transaction out of your wallet? Okay, so let's say you have an online wallet, like Bitcoin, Coinbase that you created. They do have a wallet that they do provide you inside. You need to generate an address from that specific account that you have. That's probably why you guys are not, able to get the money that you're looking for completing either signing up or completing the short videos. So you need to have an address generated from the Coinbase account, right? And then you can start doing transactions. Sometimes, and I don't know if they changed it, when you get money transferred outside on the credit, sometimes they create an account on your behalf. At least that's what they used to do. I don't remember if they do it now, because I haven't created. I showed you last time that I have almost 15 wallets, BTC wallets. So I haven't been creating, any more wallets into that. So I don't know if they change. And things did change in the meantime a lot with Coinbase. Okay, so when you go online and you access Coinbase and you have somebody else's address where you want to send your Bitcoin, for example, now you go ahead, you enter his address, you enter the amount. One thing that is good that they're doing now, and I noticed a lot of applications doing that, is one, they're validating the address of the receiver to make sure that the address that you're entering, you didn't make any mistakes, right? So if you do make a mistake, what's going to happen? If you enter an incorrect
Go to
address,
someone else.
what's going to happen?
I think you go
Does
to
not.
someone else, right? Or no?
You're gonna
Bingo.
lose your money.
You're going to lose your money. So it's going to go to a wallet that it probably doesn't exist, or if it exists, it's going to go to someone else. But basically, the bottom line, you're going to lose your money, right? So some people, like I said, were just entering stuff because it's a long string of alphanumeric values that you cannot really read. And if you have to remember it, it's tough, especially when we started all this in 2017 and everybody was not really familiar with the algorithm and the share encryption, all those things. So people were just making mistakes. Instead of putting a D, they put a uppercase D, they put a lowercase and stuff, and it's very different. So people were losing money. So what those wallets, online wallets, decided to do, those software, is they allow you to validate the addresses that you're sending. Because sometimes also people were sending Bitcoin to Ethereum addresses, and it's not going to work. So instead of entering Bitcoin addresses to send a transaction in Bitcoin, they were sending the Bitcoin into an Ethereum wallet or address. And if you do that, you're going to lose your money. That's the first thing. So now what they do, they check that the address that you're entering is actually a valid Bitcoin address. And if it's not, they're going to tell you right away, this is not incorrect, this is not a valid address. And it stops you from making those type of mistakes. Okay. The second thing that they're doing now is they present you with the fees that you need to pay upfront or an estimate of the fees, because that's probably one thing that you ran into, Pierre-Marie, right? When you were trying to get the money transferred from your Coinbase account to your Coinbase wallet on your mobile phone, right? You saw that they're showing you this is how much transaction fee you need to pay. And you can actually see all those things from, let me see, the blockchain itself. You can have an estimate. Let me pull that real quick. You can have an estimate. Like I think I showed you and I provided this link to you guys last time. Okay, so this is the Explorer. Okay, so let me check Bitcoin, blockchain, BTC, blockchain, transaction fees. Okay, so this is it. This is what it looks like. So every time you're trying to send money, right? It went a little bit high. Okay, this is the total transaction fee. This is, let me see, fees per transaction. This is what I'm looking for. The fees that you're going to be paying per transaction in US dollars. So right now it's $2. That's an estimate. That's on average. And I'm going to come back to you in a few seconds to explain to you where those fees are coming from. So keep that in mind. So right now, if you want to send $10 in Bitcoin, then you have to pay $2.71 on top of it. And you see how it went very high at some point. When was it? October 30th. It was $13 to send one transaction. It doesn't matter if it's a $1 transaction or $100,000 transaction. It's the same. It's one transaction because the content of the transaction is the same, right? Normally, to write it on the blockchain, it takes the same amount of energy, the same amount of effort. There's no difference. All the transaction information is the same. The only difference is going to be the amount of BTC that you're transferring. But the effort to write that transaction on the blockchain is exactly the same. So that's why invariably, from if you're transferring $1 or $10,000, it's going to be the same transaction fee. And that's one problem that Bitcoin has been having. And you're going to be hearing people talking about high transaction fees, the hash rate, and stuff like that. And the reason why it actually varies that much, and we're going to see a little bit more illustrated in a second what it means, is it worked exactly in the same principle, on the same principle of the supply and the demand. So the more transactions there are to be processed, the higher the transaction fees is going to go, right? So for example, if everyone thinks that the dollar is going to crash and everyone is trying to transfer money back and forth and buy cryptocurrencies, then it's going to be a lot of transactions flooding the blockchain. So a lot of the people who are doing the validation, we call them the nodes, they're going to be minimal, but the number of transactions is going to rise. So they're going to have a lot more work. So they're going to be charging more to process the transaction. And people are going to be willing to pay more because they want the transactions to be processed. I'm coming back on that in a second. But from this explanation, I'm trying to explain also to you how the Bitcoin or the cryptocurrency network is. Why do we say it is a distributed network, right? So this is an example of a centralized network. A centralized network is a network where there's a one central node, right, that controls everything that is happening on the other nodes. That means that if this node wants to communicate with this node, it has to go through the main nodes. I'm going to say that one more time. if one node in the centralized network, if one node needs to be communicating with another node in the same network, it has to go through the main node first. So if this node wants to send transactions to this node or information to this node in general, it has to first send it to the central network, and the central network is gonna route the transaction to the receiver network node. Does that make sense? That's the centralized network. The other thing is, and that's actually a good example, is what's going on in Cameroon, right? We talking about decentralization, because right now everything is coming from Yaoundé, right? Everything that you're trying to do, you have to go to Yaoundé. You want to do your passport, you have to go to Yaoundé. Well, most of the time, you can do it somewhere, you know, gather all the information in Douala in other cities, but it has to be made in Yaoundé. There's no other cities in Cameroon where we're making passports, Cameroonian passports, right? So they gather all the documents and they ship it to Yaoundé. So that's a centralized system. You have to go through the main node, which in our case, in this example, is Yaoundé. Now, if you want to move across it, and now they're talking about the decentralization, right? Now it means that you have regions taking their own destinies in their own hands. So the central node is going to be releasing some of the responsibilities to some specific second nodes that are the secondary nodes. So this is going to be the primary nodes, and then we're going to split it and have secondary nodes that are almost equal, but you still have tertiary nodes that are under the secondary nodes. Does that make sense? I'm going to explain that differently. So let's say you have one transaction that you're trying to send from this node, and you want it to reach this node, right? So this node is not directly connected to this node. That means that to send a transaction, this node has to send it first to this secondary node, and this secondary node has to talk to the other secondary node that is connected with the receiver node, and then he's going to route it to the receiver node. That's a decentralized network. Does that make sense? Okay. Now we're moving aside from that, and this is exactly what the cryptocurrency, and when we're talking about this distributed network, this is exactly what it is, this third scenario, right? So you see that in this case, all the nodes or almost all the nodes can talk to each other. Okay, so this is a representation that shows you still those wide nodes, but virtually all those nodes, if you represent that in a three-dimensional view, you're going to see that all the nodes are connected to each other somehow. That means that if this node wants to send a transaction to this, he's virtually connected to this node. It's for representation purpose, you won't see that connection. But in a distributed network, it means that all the nodes are virtually connected to each one. So if this node wants to send a transaction to this node, he can directly connect to that node. That's the distribution of the network that Bitcoin and the blockchain is constituting. Okay? Questions?
Can you let Michel Eric in, please?
Oh, give me a second. Let me see. I'm not seeing any. Oh, okay, there we go. Okay, so no questions, right? All right. So now that we understand really in terms of architecture where the Bitcoin network stands, which is the distributed network, then we can go ahead and understand what and how a transaction is working. And now you can probably, you can start on relating a little bit when we talk about the transaction fees and the transaction validations. So all those nodes that you see here, right? Those are called the nodes, the validators. So those are the nodes that are actually going to be validating the transactions. So when someone is trying to transfer you money, you're going to be connected to one of those nodes on the network. Maybe the node that is close to you, depending on your geographical location, right? And from that, your transaction is going to be routed to that machine, which is one of the nodes. And what is a node really? Technically, a node is just a computer that runs one software, with the Bitcoin protocol and code. So you can have your computer yourself right now and download all the blockchain and the software for Bitcoin to be running on your machine, and you can start, validating the transactions yourself, which can be connected to those other nodes as well. I'm going to say that differently. So if you want to do transactions validation yourself, meaning you want to be part of the blockchain, right? Because the blockchain is actually a ledger, a distributed ledger that resides on all the nodes of the network, right? So every single node on the network has a copy of the ledger. So think about it like a balance sheet, for example, or an income statement. Every transaction that is happening is going to be on that ledger written. So whenever it's written, you're going to be making sure that everything is duplicated on every single nodes of the networks. That's why it's impossible to hack the blockchain itself, because it's replicated everywhere. And if you're trying to hack one node, you have to hack all the nodes. And not only that, you need to make sure that you hack also the blockchain. And I'm going to show you how complicated it is to hack the blockchain. Okay, so coming back to, if you want to run the program, the Bitcoin program, and become a part of the node, that's basically what is called mining also. And I'm gonna get to that also in a second. So let's say you want to send a transaction to someone, right? Some BTC. You're gonna be outside of this network because you're not a node. You're not part of the node of the Bitcoin network, right? So you just have your machine here. You happen to have your wallet. You have 2 BTC that you want to send. As soon as you are sending that money, the program and the address is going to route it to the Bitcoin network that you see here. So to one node, one of those nodes, anyone that is closer to you. So it's just going to route it there. And as soon as it gets here, all the different nodes running the same program are going to be replicating that information everywhere. And everyone is going to compete to actually validate the transaction. Okay, I'm going to repeat that. If you're trying to send a transaction, a Bitcoin transaction, let's say you want to send 1 Bitcoin, okay, you have your online, your wallet, your software, and then you put in 2 Bitcoin, you put the receiver's address is validated. They're going to be telling you upfront an estimate of the fees, and the estimate of the fees is going to be based on this, right? On this, because the blockchain data is real-time updated here in terms of transaction fees and other metrics. So it's going to give you an estimate of how much it's going to be to make the transaction. And after that, when you click send, your transaction is going to be routed to the closest nodes to your geographical location. Once it's entered this node, the Bitcoin program is designed such as every node that is running is automatically replicating any transaction that gets into the net, any transaction that gets into the Bitcoin network from any node. So as soon as your transaction gets here, everyone is just going to get that transaction information as well. That's why I was telling you this is a distributed network. So all those nodes are connected to each other, right? So once you have all the nodes getting the data, the transaction information, right? Everyone on the network is going to try to validate the transaction. What does the validation mean? It means that we want to make sure that one, and I'm going to show you in the next slide probably. We want to make sure that one, this money that you're trying to send, let's say P1 is trying to send some Bitcoin to P2. The first thing that's going to be validated is that on the blockchain, there's some history of your balance. So you know how much is in the specific address who's sending the money. If you're trying to send any amount of money and your balance is incorrect, your transaction is going to be rejected. That's why you do have, I think I showed you last time in the a random address that I created. Let me see. Let's see. Let's check maybe this. Let's check this transaction. Let's check this, what a random transaction, and we're gonna see. Let's see, hash. This is the hash. Let's see. I'm gonna copy the address. Okay. So let me copy this address. All right, I think we have 10 minutes left. I'm copying this address, and what I'm going to be doing, I'm going to be coming here, and this is how much money this random address that I selected from a random transaction that is on the blockchain. This is how many Bitcoin he has been transacting, and this is his balance. He has 1,738 Bitcoins. So this is basically a whale. So if you convert that into US dollars, you're going to be seeing that is $33 million. This is a whale. We refer to anybody who is having a lot of money in Bitcoins in his wallet is a whale, because they can manipulate the market. And when we talk about trading and all that, I'm going to explain to you what that really means. But for now, I'm just making the point that any person that is sending money out has to have some balance that is higher or equal to the money that he's trying to send out. Otherwise, the transaction is going to be rejected. So in this case, this guy, I just took a random transaction, has 1,738 Bitcoins. Okay. So coming back here, that's the first step to validate that. So any node in the Bitcoin network is going to get a copy of the transaction. Is going to try to first validate that the address who's sending the money has enough balance to send the amount that he's trying to send. Otherwise, it's going to be rejected, right? And everything is written on the blockchain. So all the nodes are going to be reading the blockchain and see what's their balance. And I showed you how you can check that on the Explorer, the blockchain Explorer. You can check the balance here, but it's done on the back end through program, right? This is just a UI for you to access it easily. The second thing that's going to happen is, and actually the first thing is not even the validation. The first thing is, I told you that when the transaction is sent out, two things are happening. There's a transaction that is sent in a readable format, plain blank format that you can read. The second thing is that transaction is appended a signature. And what a signature is a hashed version of the transaction, number one. Number two, encrypted. So it's hashed and encrypted and appended to the plain text transaction. So the first thing that really happens is, I was wrong on that, I went too fast, is not the balance validation, because before validating a transaction, you need to know what's the address. So you need to read the transaction and make sure that the transaction is legitimate. So the first thing really that's going to happen is the validation, the decryption of the signature, the hashing of the plain read format of the transaction, initial transaction, and the comparison. So if it matches, then the transaction is verified. That's the first thing. The second thing, after you verify it, it means that you have access. That transaction is legitimate. You can read now the address and make sure that if the address has enough balance, you can proceed and try to go ahead and validate the transaction and write it on the blockchain. I'm going to pause for a second. Questions? Okay. So when you say,
Steph, I have a question. Yeah. How long do you think usually goes from one wallet to another one? How long does that take for a transaction?
For Bitcoin, unless there's some congestion, because I told you sometimes because of the floating of the network, if there's a lot of demand, the price is going to skyrocket and it's going to take more time, because the number of transactions to be written on the blockchain are just becoming too large compared to the number of nodes that exist in the network. But normally, that's the smart thing that Satoshi, the creator of Bitcoin, has put in place. Normally every 10 minutes, a transaction should be written on a blockchain. That's on average what it takes, because every 10 minutes, there's a new block that is created. And I'm going to explain that process also in a few seconds, down the few slides. We have 5 minutes left. But yeah, to answer your question directly, every 10 minutes, normally a transaction should be written approximately on the blockchain.
So that means those who saying that it takes more time, they're playing around with the money.
Who said that already received more
time? No, it's just some of the investment platform. Once you get them the Bitcoin to trade with.
Yeah.
They tell you that it's processing.
You should be able to see the transaction real time, because you do have your address. And I just showed you, like, you can check an address and see the transaction that he has been undergoing. You see, those are all the transactions that this guy has been sending in and out. You have the hash, the fees that he paid for each transaction, how much money he moved. You can see it here, right? So basically, as soon as you send a transaction, it's going to be pending because you need a number of validation to happen before it is confirmed, right? So we switch from pending to confirm. That means that depending on the amount of transaction, it depends. The network has to be designed such as for lower amount transactions, you don't need a lot of validations. But for bigger amounts, like if this guy was to send 1738 Bitcoins right now, he'll probably need to wait for maybe 10 nodes to validate that transaction. But for lower transactions and stuff like that, it's probably not going to take too long. And they tell you when you send a transaction. They tell you for the transaction to be confirmed, you need to wait for 3 or 4 nodes or 5 or 7 nodes to receive and validate the transaction. Okay, so that time, the 10 minutes is just an approximate amount of time because Satoshi Nakamoto designed a system such as there's something that we call a difficulty rate. So every 2 weeks, the difficulty rate is changing. So if the Bitcoin network is becoming really congested, right? Now you're going to be seeing the difficulty rate changing so that the validation is much easier, right? When the system or the network is not congested, right, it's going to make it harder so that people are not validating transactions too fast or are not taking too long either. So that it saves a little bit, approximately around 10 minutes. That's how he designed it. So every 2 weeks, what they refer to as the difficulty rate is changing. And I think I can even show it to you now. Hash distribution, total hash rate, network difficulty, okay? So a relative measure of how difficult it is to mine a new block for the blockchain. So there's a measure. You see that in December 2019, it was very low. Now it's a lot hard. It's harder to be able to mine and validate transactions. Okay, that's because there are a lot of people or less people who are transacting compared to December 2019. Okay, does that answer your question?
Yes, Steph, thanks. Mm-hmm.
Okay. So we have 2 minutes, and let me just go ahead and try to finish up with this slide. So we come back and we can go on some other stuff. So right here, what you're saying is the first thing happened. So I want to send $50. P1, I'm P1. I want to send $50 to somebody P2, right? And if I want to do it, what's going to happen is we need to validate first that the amount of money that is sent is sufficient minus the transaction fees. That's why you're seeing the transaction fees on here, right? After obviously validating that the message, decrypted and hashed, is a valid message. Now, you're going to be wondering how all those transactions getting written on the blockchain, right? Those are the 2 slides that I'm probably going to take to explain that to you. How those transactions are ending up getting on the blockchain and why we're calling the blockchain the blockchain. Okay. All right. So it's less than a minute now. Any questions before we break? Okay. No questions. Okay. All right, guys. I see you in 10 minutes. So let's say we start back at 7:20 as usual, 7:20 Eastern time. So 6:20 Central time. Okay.
Okay.
All right. Talk to you. Bye.
All right.
Bye.